Okay, so we have an objective. Oops, me and green. Is we're going to review graphing ordered pairs. And we'll go back and review this again a little bit later, but just so that you remember what this looks like. And then we're going to understand and use the distance formula. Oops, perhaps if I spelled it correctly. And how it relates to the Pythagorean theorem. So here comes the fun part. We're going to draw a coordinate system with the x-axis and y-axis, and I actually can magically make one appear. Voila. Pretty cool, huh? So there's some things missing from this. Is you see those tick marks? You're going to have to draw them in on your own x-axis and y-axis. And you have to label everything. So everybody should be replicating this on their paper. You don't have to make it super big. We actually don't need to go beyond 5 to the right, 5 to the left, 5 up, 5 down. Okay? So I think what I might do is darken in my lines. Oops. So that you can see them a little bit better. I always put arrow caps indicating they're going to go on forever. I'm going to, on mine, kind of spread these out a little bit. So I make my tick marks very clear. You won't let me write up there. Oh well, that's okay.
How many lines?
I'm going to do, you can do 4 by 4 by 4 by 4 will work. And I am going to number every one of my, oops, tick marks, hopefully correctly. When I go to the right or I go up, those are the positive directions. When I go left or down, those are the negative directions. So -1, -2, -3, -4. Now remember, you have blue, sorry, I clipped you on the head there. You have the blue lines of your paper to use to make your lines straight. And what I'm going to do is draw 3 points and create a triangle out of it. So let's see. Let's do, I'll just do this one. So, in red, and I'll just be honest with you, I have a hard time drawing dots really well, so this point here is at -1, 1. So, the first coordinate is where you go on the x-axis from the middle, and does anyone know where the 2 axes cross in the center there? What do you call that? Justin? What do you call that? The origin, okay? And the origin starts with the letter O, and that represents 0 as well, because that's where all the axes start from, is from the center, not from the edges. And then I'm going to put one over here. Shh. Come on. There we go. And that point is at 1, 1. And then we're going to put one up here. and that is going to be at 1, 4. And so if I connect those 3 points, not only do I get a triangle, I get a right triangle. And that's because I went from horizontal directly to a vertical. Now notice that one of the sides, the hypotenuse, is not vertical or horizontal. So I would have a hard time trying to figure out his measurement. But the other two I could count, right? So what's the distance from this point on the bottom to this point on the bottom? Okay, how many am I counting from to go from here to here? And I'm just, counting by a 2. So that counts by a 2. And then what's the distance from this point to this point up there? Careful. It's only 3 because I have a 4 and I have a 1. So this is a 3. So again, what I'm going to do is look at my coordinates, and I had a 4 at the top, and I took away the 1 from the bottom, and that's how I came up with a 3. And then on this one, I actually had the biggest number was 1, and I took away the -1. So when I have a double negative, it becomes a plus, and that's how I can get that answer of 2. Okay? So all I'm doing is counting, but that's because I have a horizontal and I have a vertical. I can't count when it comes to the hypotenuse, so that's when I have to use Pythagorean theorem. So we'll use Pythagorean theorem, and we're going to have a squared, we'll just make that the 2, plus the b squared, we'll make that the 3, and that equals, and we'll just call this guy, his length, we'll call him d for distance. Okay? And then we go ahead and we do our Pythagorean theorem, and we get 4 plus 9 is equal to d squared, and I use the symmetric property, and I get d squared equals 13. But I don't want to know what d squared is, I want to know what d is. So I am going to have to take, come on, Bubba. Oh my goodness. Viv. What is that one from?
Ariel.
Is that Ariel? Yep. We got Ariel outside. Square root of 13. And then we have a problem because that's not a perfect square. So here's the good news is we're going to put on this recording, because you guys are getting recorded today, we're going to put how to estimate the square root. We did it in the past, but you'll have another place to look at it. So what two perfect squares does 13 fall between? Elijah? 9 and 16. But again, it's the square root of 13 I'm interested in, so I'm going to have to take the square roots of these two guys. So what's the square root of 9? And what's the square root of 16? So my number is somewhere between 3 and 4. So how we do this estimating is we start with the smaller guy. Now I'm going to do this over here. And I'm going to add to that, what portion am I from the 3? Kenny?
3 plus...
Oh, are you already going to tell me what to do? Okay.
3 plus 4 equals 7?
No, I can't add those. So watch what I'm going to do, okay? And you copy this down. First thing I'm going to do is take my number and subtract the smaller perfect square from it. That gives me 4. That goes in my numerator. Next, I'm going to take my 2 perfect squares, I'm going to subtract them. And that gives me 7. That goes in my denominator. Now, I want to round this to the nearest tenth, so what I'm going to need to do is I'm going to figure out what 4/7 is. So I'm going to do, and I'll do it down at the bottom, just because I have more room there. And I'm going to divide 4 by 7. So I put in my decimal point, add a 0, and then I start dividing. Well, that's going to go in 5 times, which is 35, with 5 left over, and bring down a 0, and 7 goes into 57 times, which is 49, with 1 left over. So this now becomes 57, and then we're going to have to round to the nearest tenth. 7, is that going to change the 5 or keep the 5 a 5? It's going to make it up, so 7's going to make the 5 become a 6. So we would say that that distance, the length of that third side, would be about 3.6. Okay? So yeah, it takes a little bit of math to get to that answer, but you guys are all smart enough, you can handle that. So here's the problem. What if my triangle wasn't horizontal leg, vertical leg? Okay, I can't count anymore, right? I couldn't count 3.6 for the hypotenuse. So we need to come up with a better way. So this is what they came up with. Notice here that I subtracted the coordinates. Well, what if, instead of using these coordinates of -1, 1, 1, 1, and 1, 4, what if I came up with a generic set of coordinates? What if I said this point here was x sub 1, y sub 1? And this point over here would be a different x value, but he'd be at the same y value. And this point here would be the same x value as the guy below him, so he would be an x sub 2. And he would be the same, or he's a new height, so he would be at y sub 2. Okay? So now what we're going to do is come up with what we did mathematically, and we're going to plug it and create a formula out of it. So, number one, let's go back down here to the bottom where we have 1, take away -1. Looking at our new coordinates. So looking at the new coordinates of those 2 points. What coordinates represent the 1 and the -1? Is those the x's or is that the y's? So look at here. These are x's. These are y's. In order for me to do 1, take away -1. So for me to do this math here, was I looking at the x coordinates or was I looking at the y coordinates? 1, take away -1. I don't see any -1s in the y's. Ooh, so those would be the 2 x's. So we could say for this, where we had the number 2, we could say number 2 could have been the x squared, or x sub 2, which was the one on the right, subtract the x sub 1. Okay? Let's look at the 3 that we have. Okay, Sean, you're not paying attention. Well, right now you're not paying attention because we're still doing notes. So what the homework is right now is not your concern. Right now it's understanding this math. So look here and remember what we did. We did 4 take away 1 to get the 3. So looking at your coordinates, and it involved this point, which was 1, 1, and this point, which was 1, 4. What numbers did I subtract to get the 3? Did I subtract the x's or did I subtract the y's? I subtracted the y's. So to get that 3, I subtracted the y's. Okay? So right now we have the basis for doing distance formula. All right, you guys ready for this? And we'll go back to blank. To find the distance, or the length of a segment, if given the coordinates of the endpoints. Oops, got to spell that right. And here's the coordinates of the endpoints. Oops, x sub 1. So it's some value for an x, some value for a y. And x sub 2, y sub 2. So now what this is saying is this is indicating the second ordered pair. So this is your first ordered pair. And this is your second ordered pair. We're going to use these to help us figure out the length of the segment. So we're going to let D be the length of the segment. and Pythagorean theorem, the length of segment is the hypotenuse, because that's what it was in our picture. We're going to figure out our x leg. So we took our longest number, take away our smaller number, and we squared it. And we're going to add to it the longer of the two legs, that would be the y coordinates. That would be our vertical one. So basically that's my Pythagorean theorem. But the distance formula goes one step. It says, I don't really want to know what d squared is, because this isn't really the length of the segment. This is really the length of the segment squared. So what can I do if I am told the length of the segment squared, but I want to know the length of the segment? What can I do to d squared to make it d? What can I do to d squared to make it d? I can take its square root. Okay, you've just derived the quadratic, or the distance formula. So this is your distance formula. D for distance, the length of that segment, is equal to the square root of the difference in your x coordinates of the two ordered pairs squared, plus the distance in your y coordinates squared, added together, square root. Okay? So we're going to do an example of this so you can see it actually work, and it's kind of cool. Let me find a good example. Let's say you're given 2 points, 3, 2, and 5, 1. Hold on, let's just write this down, okay?
The bell, it is now time to go to 5th period. This is your bell.
So write this down. Here's your x's being subtracted and squared, plus here's your y's being subtracted and squared. What's 5 take away 3?
2.
Okay. What's 1 take away 2? Negative 1. Okay. What's 2 squared? 4. What's 1 squared? Or negative 1 squared? 1. It always would be positive. What's 4 plus 1? 5. And then what we would end up having to do is to estimate that answer. So if you know the coordinates of the endpoints, you can plug it into this formula without having to draw the picture, without trying to count, and get to your answer. Okay? All right, so 2 perfect squares that 5 falls between is 4 and 9. Square root of 4 is 2. Square root of 9 is 3. So our number is going to be somewhere between 2 and 3. So what I'm going to do is our estimation skills again, and we're going to take that 2, and we're going to add to it a fraction. Well, where does that fraction come from? That fraction comes from the difference in our number and the smallest perfect square. So that's the 1, that's our numerator. And then the second difference is between the 2 perfect squares, and that number is 5. Now, I have to go ahead and divide 1 by 5, and for us, we're really super lucky because it terminates. So 5 goes into 10 twice, and so that allows us to take this and write 2.2. So that would be our approximate answer of the distance of the segment that's formed by those two ordered pairs. All right, good luck with your homework.